theoretical data. This is not actual data. So I have a population of these 330 students where I have taken a quiz, right? Let's say 55 students scored. Is the screen visible to all of you?
Yes, sir.
Yes, sir.
So 55 students scored 1 mark. So total marks is 6. 55 students 1 mark. 55 students. So equally, right? All. So there are. So because I'm just showing you some theoretical data. So 55, 55 like that. There are 55 students who scored 6, right? Some one of you told that yes, whenever we plot, right, the data, the probability distribution of data point, that gives up certain information, right? So what I've done, so how to calculate probability? So probability of what? So randomly somebody, like let's say director says, or any my colleagues say, what is the probability of somebody in your class scoring 4, right? So I'll check the marks. I have calculated probability of that. How did I calculate probability of that? I have taken the frequency of that data point, which is 55, divided by the total number of data points, right? 55 divided by 330. So that gives me probability of 16.67%, right? If somebody says that what is the probability that this student will score above 4, from this information, what will be the probability of somebody scoring above 4?
1 minus
More than 4, sir?
more than 4.
Probability cannot be beyond 1, right?
No,
Probability
sir.
cannot.
Your question is more than 4, scored more than 4.
Yes. What
More
is
than
the
This,
probability?
The probability of 5 plus probability of 6.
1 minus this.
like, so we'll add these two. We'll get
One by
sir.
one. One by one.
0.333.
Correct. So when I say 4 greater than 4, that means somebody has scored 5 or somebody has scored 6. That are the two options. Probability of scoring 5 is 16.66%. Probability of scoring 6 is 16.66%. So that is around 33 point. How much is coming? 33. 33%, right? 33% is right. So when I plot this, right? So what I'll plot the marks 1, 2, 3, 4, 5, 6. And I have plotted the probability of that mark. Somebody scoring 1, the probability is, so all of them are equal probability, right? So what kind of distribution is this? So what kind of distribution when probability of all the variables are same? What kind of distribution is that? Okay, if you do not name the one, it is a very simple and uniform distribution because all the variables are uniform probability, right? All the random variables which I have taken have a equal probability or uniform probability of happening, right? So this is a uniform distribution. It could have been a normal distribution, it could have been a beta distribution, it could have been some other distribution. But for my example, I am showing you. So it is not necessary that it will be always uniform distribution. For my example, I have taken a data such a way that it is only uniform distribution. But for what I am creating that distribution? For the population. For the question which I am discussing, my population is though 330 MBA student, right? So that is a, for me, I have taken that as a uniform distribution, right? So whenever I'm plotting the information about the population, that shows me a population distribution. The distribution can be different. It can be normal, it can be a uniform, it can be a beta distribution. I do not care about that because 100% of the time I will not have information about the population, because if I have the information about the population, why to carry out a hypothesis testing? I have all the information. So there is no need of hypothesis testing. But here I want to show through an example. That's why I'm showing you. I have the information about population and how that converts to a central limit theorem, right? But remember that this population information will not be available. Last class we were discussing something about the usage of Netflix. There are might be 5 lakh people or 10 lakh in India who are watching Netflix or who have subscriptions for Netflix. Company might have all the information because, but as an outsider, I do not have information, right? But if I want to study on the usage of OTT platform, company will not give me that information. How to collect data? I'll go and collect sample. I'll never have the information about the population, right? So this is something again, just to show you, right? If I have theoretically all the information about population, I can plot that and I'll get a population distribution, right? So that is about the population part. But let's say I do not have, I lost all the information. Somehow my hard disk got corrupted. I do not have information, but somehow I have only information left about those 30 students, right? I have information randomly of some 30 students out of 330 students. So when I check that Excel file, out of those 330 students, I have only information about 30 students. So in that, out of that 30 students, 1 mark, there are 5 students who have scored 1 mark. There are 6 students who have scored 2 mark, 5 students who have scored 3, like that. This is the distribution, right? So if I plot that, again calculate the probability. So how will I calculate probability for this sample? Frequency is 5 divided by total sample size is 30, right? So that will give me the probability of probability distribution. Now when I plot this, right? So this is the sample distribution. You will always have the information about the sample, because what you are doing exactly, you are collecting sample size of 30, 50, 100, 80, right? So you, if I kind of plot that, right, it obviously it need to be a continuous or a interval or ratio kind of scale, right? I cannot plot a categorical data and put the CLT. Anyhow, that we'll discuss later on. I have a continuous data which I'm plotting. So again, if I plot this, this is not a uniform distribution because probability of each variable is different, right? So this is what a sample distribution, right? So I hope everything is clear. What is a population distribution, which I do not have information on. What is a distribution size, distribution format of a population, I will never know. But in this case, because I am showing the information about 330 students, I have the information, I'm showing you that. But when you actually do summer internship or any kind of project, you will never have any information about population. What you will have information on? The data which you are collecting, that is about the sample. Based on your sample size, the distribution will be something like this or something else, right? But if you read about the central limit theorem, what it says, something about the sampling distribution. Now the question is, what is that? Because when you read about it, you search on Google, it doesn't talk about the population distribution. It doesn't talk about the sample distribution, right? It talks something about the sampling distribution. Then what is that sampling distribution? Anyone?
Sir, the number of samples which we have taken, is it?
I have taken 30, my sample size is 30, right? I have taken one sample, that is 30.
So, sir, I think it states that the number of samples we are using in that particular.
But 99% of the times you are not going to collect multiple samples. You are going to collect data one point of time. Your sample size will be different. Rather than collecting 30 data points, you might collect 100 data points. That is your sample size. But number of samples is one. Unless you have a panel data or a cohort data, you have a different kind of longitudinal survey. It will be for your summer internship or for any kind of project what you will do in class. 99% of the times you are going to collect data only single time. That is a cross-sectional design. So that is number of samples is one. Sample size, that is the number of data points you are collecting. So when in that, but you are not wrong. It is talking about something on number of samples, right? What is that then? Because I'm collecting data only once, which is sample size of 30, 50, 100, right? Then what do you mean by that sampling distribution?
Sir, it states that the number, like, what's my sample size? Is it large or it is small? So on that basis, we define
Range, sir, range of the sample size.
Range is here I have taken 30, right? It can be maximum 330, right? Because I cannot take beyond 330 because that is my population size. Lowest I can take 1.
So
My range is 1 to
we
330.
can say,
Yeah.
so a probability distribution of all the possible means of sample is a like it can be
Okay.
said as sample.
So probability distribution of all the possible samples, right? So how will I get that? Because that is what I am to like understand, right? So what you told is correct. So probability distribution of all the possible samples, right? But I'm collecting, like I said, I am collecting sample only once. Sample size might be like if I ask you to collect data tomorrow, maybe 70 student you will collect or 100 student. Once I define that what is your sample size, there is a formula to calculate sample size. That many data points you will collect. But sample is one. Only single sample you are collecting data.
So we can get the average of it and then.
But average of what?
Okay.
Average of this one is 3.53, right? You have collected data. the average marks scored by the student, if I take the average sample mean of this 30 student, is 3.533. That is only one mean. So when you say that the probability of all the sample means, how will I get that data? So what you told is correct. So that is the way, but that is a theoretical or hypothetical scenario, right? I'll never have the effort, time to collect that many samples. Just look at this number. Number of ways to take 30 samples, right? Out of 330 students. What it says, if I have 330 students, I'll pick randomly 30 students, right? Randomly I start picking 30 students. How many ways I can do it? So how many samples I can create? 330 combination 330 C30. These many number of ways samples can be created. These many number of possibilities of creating different samples. Obviously, I'm not going to that many data points. Obviously, I'm not going to collect that many samples, right? So when you talk about a sampling distribution, remember that is always a theoretical or hypothetical distribution. It is not that we're going to collect that many samples. This is a theoretical or hypothetical distribution of if theoretically it was possible to take all the sample of 30 size each out of 330 students, and I started plotting that, right? Then that distribution of sample means would have been a normal distribution. So let me show you through that example, because obviously I cannot show you this many samples. What I have done 1,000 samples, right? So what does it mean? Sample 1, right? So I have collected first sample. So student 1 scored 1, student 2 also has scored 1, like that 30 students have scored different marks. So I have total 30 students in my sample 1. Like that, let's say again I go and collect sample number 2, right? Sample 3, sample 4, like that I have collected 1,000 samples, right? So up to 1,000 samples I have collected, right? So for each of those samples, what I've done, I have calculated what is their mean score. Sample means are like this: 3.53 for my first sample, which is have shown in the top. For sample 2 is 3.26, for sample 3 is 3.03, like that. There are different sample means. So your central limit theorem says that if you start plotting these sample means, right? The central limit theorem states that the sampling distribution of the sample means. So when I plot that means in my x-axis and the probability of that means in my y-axis, that distribution of sample means, which is known as sampling distribution, that will be a normal distribution, right? So this is, again, it is not that you are collecting that many samples, because just see that I have only taken 1,000 samples. It is almost normal. It is not perfectly normal, because for that to happen I have to take that many samples, which is a very big number, right? But by taking only 1,000 samples of sample size 30, I'm creating a distribution which is almost normal. So population distribution, which is unknown, you are only collecting one sample with sample size 30, 50, 100. So that is sample distribution. Sampling distribution is a theoretical or hypothetical distribution. If just imagine the scenario, there are 330 students in the auditorium, right? Randomly I call out roll numbers 1 to 30, not 1 to 30, randomly I choose roll numbers, right? So 30 student I pick. So that becomes my sample 1. Then again, another 30 students, randomly I choose the roll numbers, that becomes my sample 2. If I keep doing that for 1,000 times, right? So that will, and if I start plotting that, that will give me this kind of sampling distribution, right? So whenever you talk about central limit theorem, it talks about the sampling distribution, which is a theoretical or hypothetical distribution, right? Is this part clear? What is a population distribution, sample distribution, and sampling distribution?
Yes, sir.
Okay.
Yes, sir. Sir,
So,
one question.
Yeah.
So when we are taking that random sample, for example, first we chose some of the students. So when the next time we will choose, So is it going to like include some of the students?
Yes, it can.
we
It
have-
can. It can include. Even with a.
So I have the same question, sir. So
Yes.
in combination, when we are taking out, like suppose there are 330 students and we are taking out 30 samples, so is the duplication avoided or duplication can happen, like one student going into different samples?
Yes, yes, that is possible, and that has to be there with repetition. So whenever you are collecting data, so if you read the central limit theorem, it talks about data collecting with repetition. Otherwise, what will happen? The mutual exclusiveness will have not happen. Think about a deck of cards, right? If a magician comes and says that, okay, I can tell about that, okay, which card you are holding. But if you start keeping those cards out without bringing that into your deck, the probability of him guessing a right card will increase, right? But because when we talk about central limit theorem, each student have a equal probability to become part of any sample you are taking, right? So it is with repetition. That means obviously two samples cannot be exactly same, but there will be a probability that okay, if sample one there are 29 students who are common to sample two also. One student might be different because if all the 30 students are same, both are the same sample, right? There is no difference. But to answer your question of the repetition, not only one, in two samples, 29 students can be also repeated. So sample one, sample two, 29 students might be common. Only one student, some student is different in sample one, and some student is different in sample two, right? Yes, it is with repetition.
Sir, in
So-
previous question,
Yeah.
which type of distribution was there in previous question, sir? In
Which
previous-
previous question?
Sir, when second question, sir. First was uniform, this is normal, and second question.
That is a non-uniform distribution. That doesn't follow a proper skewed distribution, right? So that is a non-uniform distribution.
Okay.
So, sir, if the repetition is happening, so isn't so how we will get the like proper data? Because if the repetition is happening, so like the responses can be same.
But you are not collecting that data, right? Are you going to collect 1,000 samples? It will take you a lifetime.
No, sir, but in few of the cases, like where we have to do for like 30 to 40 samples or 20
Never.
samples.
So that's what I'm telling. When you collect 30 to 40 samples, do you believe that how much time it will take 1 year? Do you think that you'll go to Reliance Retail for a study 30 times you'll go?
No,
So
sir.
each sample is 30 or 40. So what you are talking about is the sample size, the number of data points in your sample. You are collecting data only once. Unless it is a
Okay.
longitudinal survey where multiple years, multiple data points. What you in SIP or any kind of study, at least in the academic level you cover, is mostly cross-sectional design. That means you are collecting data only once, one sample, all of them part of only one sample. Data point size might vary. Sample size, let's say if you do a study of 100 students, somebody else who is doing with a 500 students. So for you, sample size is 100, but the other person sample size is 500. For him, the results might be little better, right? But sample you are collecting only one. You are collecting only one sample. In this particular case, the information what I showed, if I do not have any information, I have lost the Excel file. I have only information about 30 students. Based on that, I have to make a judgment about 330 students because I do not have any other information, right? It is not that I'm going to collect. So that's why I repeatedly telling this is a hypothetical or theoretical distribution. It is not that for every question you have to create a sampling distribution. So I'm repeatedly telling this is a theoretical. If I'm able to create a distribution of sample means that will become a near normal, close to a normal distribution. If you see that with 1,000 sample also, I'm able to create almost close to a normal distribution, right? Is this part clear?
Yes, sir. Yes, sir. Sir, if we are evaluating like some students based on the what scores they have in the in math subject, so in the starting of the year we do a baseline test, and at the like end of that year we do an end-line test. So in both of the cases, when we are choosing the sample, so is it going to be same, or like how we will select sample in this case? And the schools, number of schools are like 5.
It depends upon what kind of study you are going to do, right? So it can be whether it is experimental study for those same group of students, those 30 students. certain kind of innovative teaching method was utilized. So you'll test again with that 30 student. But let's say all those 330 students have gone through the random whatever lecture method or online method or offline method all equally, right? So in that case, randomly you select any 30 student, right? Those 30 students need not be exactly same. But if let's say in this particular case, now what will happen? Out of all those 350 students, few students will be in campus from your batch, right? And they will go through the offline mode. If I want to do a comparison, how these students are doing in comparison to online student, how is their knowledge level, right? So in that case, the like kind of study of the experimental data, your control group and your experimental group comes into picture, right? But again, like the method testing remains same. Only thing you have to realize that whom you are studying. In my case, what will happen? If I am all those 330 students going through the online classes, no differentiation, right? So in the first starting of the semester, I'll choose 30 students. What is their knowledge level? In the end of the class, I'll choose randomly 30 students. Out of that, some student might be common, 5 or 6 students who are there in the first sample, right? Then I'll compare whether actually their knowledge level have increased, right? But if it is a specific group of students, which let's say are going through the offline classes, so I cannot compare, okay, I'll take offline student 30 students, then I'll take an online student. So that comparison will be faulty. So I'll take 30 students in the beginning of, let's say, March first week, when the offline classes happen, their knowledge level. Then maybe after whatever 2 months down the line, their knowledge level. Because see, whenever I'm taking the characteristics remaining same, characteristics, if they vary, it will be very difficult to compare.
Yes, sir.
Okay, I hope this part is clear. Anyhow, I'll share the slide, go through it. But this part need to be very clear. Otherwise, we'll not be able to form a hypothesis and go about the hypothesis testing. So there is something called a population. If I have the information about population, I can draw population distribution. But 100% of the time, I will not have information about population. Out of population, I randomly select a sample that gives the sample distribution, right? I am also not interested in what kind of distribution it is. I can do some descriptive analysis so that, okay, frequency, mean, and all those things. But that's it. For hypothesis testing, what kind of distribution, I do not care. What I am careful or what I want to understand is that whenever I theoretically take all the sample, theoretically, I am able to take all the possible samples. In this particular case, out of 330 students, I can take this many number of samples and start plotting their sample means. So that will become a normal distribution, and mean of this sampling distribution will be same as your population distribution. So if you see here, let me just so what was my population mean? If I go back and look into that number, I have 55 students, each scoring 1 mark, 2 mark, up to 6 marks. So population mean was 3.5, standard deviation was 1.70, right? So for the particular sample which I had chosen, right, my sample mean was 3.53, sample standard deviation was 1.52, right? And for my theoretical 1000 sample, it is not actually a proper sampling distribution because I have only taken 1000 samples. Because in the Excel file, obviously, I cannot show you that many number. So when I take the mean of my sampling distribution, right, of those 1000 samples, it is coming as 3.4971667, and standard deviation is 0.302, right? So what your central limit theorem says, as and when you actually start taking all those samples, right, which are theoretically possible, the distribution of sample means will be a normal distribution, and mean of that sampling distribution will be close to your population mean. If you see it will be close to your. So because this I have taken random numbers, it will keep varying. So these all are random numbers. So any number of samples I take, if it is like close to the equal number of samples which I can theoretically take, it will become close to my population mean, right? So this is the definition of a central limit theorem. So now the question is, what is the use of this, right? So we talked about the population distribution, and you will tell that, sir, you were telling I will never have information about population. Then why to use this sampling distribution? Exactly for the same reason, because I do not have information about population distribution. But statisticians and mathematicians have created different sampling distribution for me for different scenarios. What kind of sampling distribution can be? So they have already created for me. I'm not going to create that. All those normal distribution, t distribution, what you see, those are nothing but sampling distribution. So that table has been created for me to help me to find answer to my question, right? So now the question is, by using those sampling distribution, can I find a answer? What answer I'm trying to find? So in this particular case, one of my hypotheses can be, because let's say this is the first year I'm teaching your class, right? I do not have any information about previous batches. I do not know that how good you are, or how like, or what is your knowledge about this research methodology, right? So, and I did this sample and I took a test of 30 students, and I get this mean as 3.3, right? So now I have to form an hypothesis. So how to form a hypothesis? Hypothesis has to have certain basis of it. So when you talked about that assumptions, which can be statistically or mathematically verified by collecting data about a sample, right? What we actually are talking about, that assumption what I'm going to form has to have some logical basis, right? It cannot be like in this particular case, one of the assumptions can be the average scores of student in BRM class will be around 4 or 3 or 3.5. So those assumptions can vary, right? How to make sure that that is a basis? So ideally, what I should do, if I'm carrying out a test, I'll go and ask the professors who have taken your classes, how these students perform. So let's say some professor told that, okay, so they are around, they'll score around 60% on an average. They score at on average score will be around 60%. So 60% of that will be 3.6. So when I'm forming a hypothesis about your performance, my hypothesis can be something like that, whether the average score is greater than 3.6 or less than 3.6. So the point what I'm trying to make is that whenever you are framing a hypothesis, it needs certain basis of it, right? Last class we were discussing some questions about how much time people in India spend on Netflix, right? Let's say tomorrow you want to carry out a study and you want to understand whether it is greater than 4. I am going to ask you, why did you take 4? You'll say that because I think that I watch around 3 to 4 hours a day, that's why I took 4. That will be wrong. So when I say that, you should have certain evidence which you have collected. So maybe a secondary search, you search on Google, you read about certain blogs, somebody who has already done research, right? And they have told that, okay, on an average, students watch 2 hours, a student watch 3 hours. So that should be a basis of your hypothesis. Hypothesis cannot be formed based on my assumption, because that will be a biased hypothesis. That will be a wrong way to form an hypothesis. So whether for your summer internship or any class project, whenever you are framing a hypothesis, it needs to have some basis behind it. So how it will happen? Either you'll do a qualitative study, you'll go and ask some of your friends, some of your colleagues, how much time they watch, and that whatever qualitative study you do will help you to form a hypothesis. Or you need not do a qualitative study. Some information might be available on internet also. Let's say you are doing a study for ITC, FMCG company ITC. You want to understand on an average when they pay their distributors and dealers, right? What is that payment mechanism, right? So that information is not available on internet, right? You have to go and ask their managers. Okay, they say that, okay, we pay around in 21 days or 15 days. So that becomes your starting point. So whenever you are forming a hypothesis and you want to understand on an average FMCG companies, how many days they take to make a payment to their distributors or dealers. So that 15 number has to have some basis. You cannot make that assumption. Somebody who is expert in that area, who has experience in that area, you have to get that number and start with that. Yes, Harsh Prakash.
Sir, if we take an example of like any like OTT platform, so I have launched a new OTT platform and I want to create like a social media page starting from Instagram. So I want to do my some profile analysis. What type of content should I post on Instagram so that it can like attract some crowd, and my page becomes more attractive, and like many people will follow me. So when we are doing that profile analysis, so how should we start? Like, what can be the step one through which I should go and decide, okay, I have to do the profile analysis of this much number. So how should we start it?
That is no, so that is completely different. That is a social media analytics. You take a content, you will test it. So there are different testing, A/B testing, content analysis, multivariate testing. You'll put some content, you'll show that to certain audience. You'll note down their response. You'll create a different content. You'll show it to a different level of audience. You'll note their response and compare the responses. That is different than what we are studying here.
Sir, but I have to do some profile analysis. Like I don't know how things.
Yes, so that is a
used to
digital
go.
marketing analytics you have to study. You have to study about A/B testing, multivariate testing.
Okay, sir. So in that case, like if I choose 4 profiles, so like my statement is invalid, what I feel. So like how I should come up with this number? Like I'm going to do 5 profile analysis, and based on that, I'll decide, okay, this type of content I should post.
That is again for whom you are doing, for the company or the person you are doing. You have to take their input because you do not have knowledge about that sector, right? Unless you are like
sir.
well known about in that sector, you have understanding about how many people are posting in that area, you will not able to take that call. You have to ask for the person whom you are doing the study.
Okay, sir. Okay, sir.
Yes, through Sally.
So you said having more than like having a lot of samples is never practically possible. But again, for hypothesis testing for a sample, when we say that we need to have a predefined mean, and based on that we do the testing. So how do we
Predefined?
predefine that mean? Given we already have a given mean, and
Not
we
mean
check
actually certain information, right? Here.
certain
You need to.
information. So how do we obtain those information?
Correct. So that's what you have to do a study, right? Qualitative study or secondary research, or you have to go and ask the experts. So in this particular case, let's say you want to study about the Netflix, how many hours people watch youth in India, how many hours they watch Netflix, and you want to do a primary research. So your hypothesis can be whether it is greater than 4 hours or whether it is greater than 3 hours. Somebody else who is doing similar study, he might take 5 hours or 10 hours. So if you just take your opinion, different people, all of you can take different numbers, right? So that's why qualitative study is important, or the opinion of experts are important. So you'll go and find out those people who have already done research, right? And from that number will come. Okay, so let me show you an example. I hope that will be a little bit clear. So a lot of discussions are happening regarding farm loan, right? Farmers are taking loan, right? So if I want to make a study on Odisha, that okay, what is the loan amount on an average for farmers or the households who are kind of carrying out these farming activities, right? What is the average farm loan? If I do not have any information, if I start a hypothesis that okay, it can be 50,000, 1 lakh 50,000, 2 lakh, 5 lakh, that will be a very wrong hypothesis. I should have a justification for putting that number. So in this particular case, what I've done, I have gone through, and ideally I should take 4 or 5 sources. Because this reporter might have wrong data, who have written this the print.in, that data might be wrong. So ideally you should collect some secondary data which is available on internet. If not available on internet, talk to the company. If it is something related to the company you are working for, talk to the manager. Let's say you are working for a small this NBFCs, right? Non-banking corporations, right? Some data will be only those people only will know. That might not be publicly available on internet. So before framing a hypothesis, you need to get that information, and that is where your qualitative research will come into picture. Interviewing, focus group, or some kind of secondary research. Secondary research means already data available on internet or some report. So in this particular case, if I want to study about what is the farm loan on an average, how much loan farmers in Odisha are taking, right? So I have taken this article, and that will be my point of reference. So if I read this article, it is saying that 52.5% of all agricultural households in India were indebted with an average debt loan of 1.04 lakhs, 1,04,000, right? So that was back in 2018. Right now, I want to do that study in 2022, but I should have a base. So I'll say that, okay, I have gone through 8 or 10 articles and these are the results. So that helps me to create a hypothesis, right? Did I answer your question, Trusal?
Yes, sir.
Sir, from
So-
8 to 10,
From?
sir, from 8 to 10 articles, suppose if we get a different number from
So
instead of
again,
52.
yeah, obviously you'll get different numbers. So that is where the reliability, right? If somebody like some student has written a blog, whether you will believe that or somebody who is from Hindu or a economics, their data will believe. So that depends upon from where the source of the data, or some research reports which are published in very good forums. So that is where you have to take, like, these are the numbers I go, but these are the few articles which are recommended or which are very much reported. So I'm taking this number. No, never it will happen that all the numbers will be same. Somewhere it will be written 50,000, somewhere it will be written 3 lakhs, right? So take those numbers which is little bit reported, like from the place sources are well known, right? Or let's say newspapers like Hindu, Economics, those will be like reliable sources of data. Because you believe that, okay, let's say they would have done their homework before publishing something. But if somebody has written just like a student has published his report and you take that data as your starting point, so that will be a wrong hypothesis.
Okay, sir.
So now if this is my research objective, right, I want to understand agricultural household debt amount or the loan amount in Odisha is greater than 1,04,000, right? Wow, what will be my hypothesis? How to go about in forming my hypothesis?
So, sir, it should be like mm, sir, like if it is if we are assuming that it is greater than or greater than 1.04 lakh, so that
Yes.
can be my assumption.
So the
Yeah, so
average
that's what
debt
I'm
per
asking. Like,
Assumption is
that's what
zero, so null hypothesis 1.04 lakhs and
no. So you have
alternate
to tell me that statement, right? So when I say that null hypothesis is one, yeah.
Sir, average debt per agriculture household in Orissa is greater than 1.4 lakh.
1.04 lakh.
1.04
What is that?
lakhs.
What is that? Null hypothesis or alternate hypothesis?
So that's
Null, sir.
null
hypothesis.
hypothesis.
Somebody else was giving some answer, or all of you agree that that is a null hypothesis?
It's a null hypothesis. So because we haven't conducted any experiment yet to verify that statement.
So, but in null hypothesis, we will see no if it is greater than equal to or
Yes, sir, greater than, equal to, or smaller than.
No, don't
In the-
never get into all that kind of trap that, okay, if there is a symbol, that is a null hypothesis. So the step to approach this hypothesis testing is whatever you want to prove. See, if it is a like a regular thing, right? In summer season, temperature is high. That is a common sense. Everybody knows that, right? So that is something I'm not going to prove. But on a particular date, if parameters are same and based on the past data, I can predict it, right? That is something I'm interested in, right? Which is alternative theory, right? And so like in YouTube and all those things, you have studied about aliens are there, conspiracy theory, right? Think it in this way. If aliens are not there, everybody knows. But if I prove something that, okay, this shows that aliens are there or ghosts are there or whatever other things which people do not believe. So that is something which will be curiosity or which something is different, right? So that is the alternative theory. And that is always I'm interested in. If it is everybody knows that, okay, this is true, what to prove there? I have to prove something which is new, which is interesting, which is alternative. So other way around is whatever your research objective is, that always becomes your alternative hypothesis. Put that as a statement form in a mathematical form, that becomes your alternate hypothesis. So first write down your alternate hypothesis. Opposite statement of that will become a null hypothesis. So this is the simplest approach to whenever you have confused or you are confused to write a hypothesis, whatever your research objective or problem statement, write that as a mathematical format and that becomes your alternative hypothesis. Exactly opposite of that becomes your null hypothesis. So here what I want to prove, agricultural household in Odisha is greater than 1,04,000. Same statement I'll write, that becomes my alternate hypothesis. Average loan amount by farmers in Odisha is greater than 1,04,000 in other way around, because I'm interested in all the farmers, not only my the sample of 100 farmers or 200 farmers, right? So that is the mu, that is the population, sorry, population mean. So I'm writing into a mathematical formula, mu is greater than 1,04,000. This is what I'm interested in. This is my alternative story. And this is what I'm interested in. Opposite of that will become the status quo. If that is not true, my alternative story is not true. Opposite whichever is the status quo, null means no change. That
Yes, sir.
is my null hypothesis. So what will be my opposite statement of that? Average loan amount is less than
Less than
equal to
equals to 1.04 lakh.
right. So always remember, whenever you have to write a hypothesis testing, first write the alternative hypothesis. It is very simple. Whatever you want to prove, that is your alternative hypothesis. That is my alternative story, right? And that is my alternative theory, which I am interested in. Opposite of that will become a null hypothesis, right? So what about this student farmers, sorry, parents who send their kids for higher education, on an average they spend on, that is HSBC survey, and they had taken how many? Well, 500.
Alternative.
No, it is not.
Alternative hypothesis.
No,
Sir,
it is
because
not
it is
other way
less than-
around. It is not other way around. If the objective is like that, that is not your alternative hypothesis. From your objective, alternative hypothesis will come. So it is research objective doesn't mean that it is alternative or a null hypothesis.
Yes, sir.
Your research objective will be given. From that, you have to form an alternative hypothesis. So it is not that I'm asking this is alternative or null hypothesis. This is a research objective. This is what I'm interested in. Then what will be my alternative hypothesis?
The
Less than INR 361975.
Correct. So that is what I want to prove. What I said. What I want to prove, that becomes my alternative story. That is what I want to understand. Average spend on tuition fees. Obviously, I have to write the full statement in higher education in Odisha is less than 361,975. So mu is less than 361,975. Opposite of that will become my null hypothesis. Yes, Harsh Prakash.
Sir, if in this statement I want to prove that the average spend on tuition fee is greater than or equal to INR. So that's what I want to prove. So, in that
So you
case,
cannot
that-
prove greater than equal to. You can prove greater than one.
yes, sir, greater than. So in that case, that will be alternative hypothesis for me.
Yes.
And the reverse will be this one. Yes, sir.
Yes. Yes.
Okay, sir.
So in this particular case, if let's say rather than proving less than, you want to prove greater than, that will become your alternative hypothesis, because that is what you are interested in. Then the opposite of that, less than equal to, will become your null hypothesis. In this case, because I have written, I want to prove whether it is less than 361,975, that becomes my alternate hypothesis. That is the alternative story I am interested in, theory I am interested in. Opposite of that will become my null hypothesis. Where I have taken this number, I have at least a newspaper article to show that. But ideally, like I said, whenever you are doing an internship, you should have a justification around it. Either a internal resources, which is for your company manager to whom you are reporting to, or some qualitative study or some secondary research. It has to have some basis, right? Otherwise, I should have put it is less than 4 lakhs or 3 lakhs or 5 lakhs. It should not go about my own assumption. Okay. 12:45. Okay. Any questions or any doubt on this?
Sir, can't we determine it by simple symbols that alternative hypothesis involve smaller than or greater than, and null hypothesis involve smaller than equal to and greater than equal to?
Equal to sign will be there because there is a status quo or no change. Equal to sign will be there in the null hypothesis. But
Okay,
knowing
yes,
that,
sir.
you will not able to know that whether if it is a greater than symbol,
Yes, sir.
which kind of hypothesis is this. So if I tell you there are three types of hypothesis: right-tailed, left-tailed, and a two-tailed test. What kind of hypothesis is this?
Sir, alternative.
No,
Because it
alternative is
involves
given.
both.
See, alternative I
Yes.
have written already. So this hypothesis, what I have written, whether it is a right-tailed test, left-tailed test, or a two-tailed test.
The two-tailed.
TwoTail, sir.
Why it is a two-tailed? So
Sir,
when
because
you go,
it involve both smaller than or greater than equal to. Means
where
her-
it is involved?
Means there are consequences in lower side and higher side.
Lower side, so that will be consequences everywhere, right? So I cannot. So if I take both the hypotheses, one hypothesis will be greater than other hypothesis will be opposite of that. So that is then all the test will be two-tailed test. Getting it? If other way around, if my alternate
Then
hypothesis
it
was
is
greater than,
left tail test.
Sir,
Correct.
it is a left tail
Because
test.
average spend on is less than the
Yeah.
INR3.
so
True,
the
true.
philosophy behind it is whenever you are framing a less than, it is a left tail. Why you are telling a left tail? Because in the number line, when I put my mean will be in the center in a normal distribution. I'm assuming the information what I'm collecting will show me that mean is actually left side of that. The information what I'm collecting is left side of the mean value, right? So
Okay,
left
sir.
side of the mean value is left tail test. In the previous slide, what I said, it is greater than 1,04,000. Mean is in the center. I am telling that it will, because in the number line, what happens? The larger the number, it will be in the right side. Smaller the number, if I start from some negative to 0 to the positive, larger the number, it will be in the right side. Lesser the number, it will be in the left side. When I'm
Left
saying
side.
that this number, what I'm getting will be greater than, that means it is larger than the mean, 1,04,000. That means it will lie on the right side. So that is
Right
why it is a
side.
right tail test. If I convert this to a two-tail test, how it will happen? If I want my research objective to show that it is a two-tail test, what will happen? What will be my research objective in this particular case?
Sir,
So
is
both
it
side,
in between
so both
statement?
side and
So what will be my
So
research
mean-
objective in that sense?
Sir,
What-
it will be
what I'm
written.
trying-
Should not exceed a certain amount and it should not go beyond certain limits. That is a two-tail.
in a single hypothesis test, you cannot carry out both of them, right? Remember, if I'm making a hypothesis statement, writing that it can be greater than or this and less than this, that is not possible. So whenever we are talking about two-tail test, we are simply talking about equal to or not equal to. So in my research objective, let's say my research objective is whether I want to understand it is exactly 1,04,000. The average agricultural debt amount or the loan amount in Odisha is 1,04,000. That is something exactly 1,04,000. If that is what I want to understand, my alternative hypothesis will be average loan amount by farmers in Odisha equal to sign 1,04,000. Opposite of that will be not equal to, right? Average loan amount by farmers in Odisha not equal to 1,04,000.
Yes.
So when you talk about not equal to, what does it mean? If I say that A is not equal to 10, that means A can be less than 10 also, A can be greater than 10 also. But in null hypothesis, you cannot write that it can be greater than or smaller than this, right? You have to write that it is not equal to that number. It's not equal to 1,04,000. So that is a two-tail test because it can fall under left side also, it can fall under right side also. What I'm interested in, whether it is exactly the mean value, the 1,04,000, right?
Yes, sir.
So that is what I'm interested in. That is equal to sign I'll put in my
Two-tail test.
alternate hypothesis.
Alternate.
That means average loan amount is 1,04,000. That becomes my alternate hypothesis. Opposite statement of that, not equal to, becomes my null hypothesis. And this becomes a two-tail test. Why it is a two-tail test? When as I am trying to prove it is equal to, that means I'm trying to say that it doesn't fall behind that left side of mean, neither in the right side of the mean, right? It exactly falls on the center, right? That is my two-tail test, right?
Yes, sir.
Any questions, any doubt? So right tail test, right? What I'm trying to prove is that whatever my population mean is greater than some specified value, whatever value I'm getting, it is greater than some number, whatever assumption. Again, that assumption need to have some solid basis, right? Assumption cannot be out of air. It has to have some qualitative research or secondary research. Left tail test, when telling that whatever number population mean I'm trying to achieve is less than certain number, right? TwoTail is when you have no theoretical reason for specifying a direction, neither left side or right side. The research hypothesis, we conduct a TwoTail test. The research hypothesis specifies that the population mean is not equal to some specified value, right? What else? Assumptions. Assumptions, whenever you are carrying out a hypothesis testing, all statistical tests assume random sampling, right? So a random, that word is little biased whenever we use that in our normal English language. Randomly, it is raining randomly, or the temperature weather is moving randomly, right? So normally we use that word in random. But whenever we are talking about the research, whether business research or marketing research, random means each of those participants, each of those respondents whom I am studying have a equal chance of being the part of my study, right? Like I was giving that example, let's say some of you who come to campus and I only provide some certain survey or give some data point to work on to those 30 students, and based on those 30 students I make an assumption or judgment about 330 students. That will be wrong, because what happens, those survey which I'm taking only consider those 30 students who are in campus. That doesn't consider other students who are not in campus. So that is not a random. Imagine a scenario where actually you are doing a summer internship. Collecting random data is very difficult, because what happens, your company will give you a list. Okay, these are my customers, these are the customers list. How to find out or how to make sure that you are collecting random correspondent? Otherwise, what will happen? I'll start calling customer one. If he doesn't pick up my now like number, customer two, like that I'll go. Once I reach 30 customers or 40 customers, I'll stop my serve. So that is not random, because what happens in that case, those people who are above, like customer ID is above 100, I'll never going to connect with them, right? So how to create a random sample, you must have gone through the sampling techniques, but we'll discuss that in detail again when we come back and discuss about hypothesis testing. But remember, it is very difficult. Most of the surveys, most of the studies which you will do, 99% of the times sample will not be random. Okay. Test of hypothesis about means also assume interval or ratio level of measurement. That is where your continuous data, right? So CLT, whatever the central limit theorem, is applicable whenever you are collecting data in a continuous scale. So there are two types of data, right? Continuous data, categorical data. If your data is nominal and ordinal, that is categorical data. If your data is interval or ratio, that is a continuous data, right? So this theorem is only applicable is whenever we have a continuous data, interval or ratio data. Population under consideration be normally distributed, or that the sample size be larger than 30, right? Remember the condition. What I showed you, my population distribution was not normal. It was a uniform distribution, right? So it doesn't matter what is your population distribution, as long as you are collecting good, your sample size is greater than 30. Your population can be uniform, non-uniform, beta, gamma, normal distribution, any kind of distribution. It doesn't matter, because anyhow I do not have information also. I do not know what kind of distribution my population is. As long as for the continuous data I'm collecting sample size is greater than 30, right? I am 100% guaranteed that the sampling distribution, the theoretical distribution of sample means will be a normal distribution, and that is what I'm interested in, right? So population distribution can be normal. If it is not normal, as long as I'm taking more than 30, my sample size is greater than 30. Remember, when I'm talking about sample size, you are collecting data only one. Sample is one. Sample size is 30. It is not that you are collecting 30 samples. You are collecting sample only once with a size of 30, 50, 100, whatever that is, right? So research hypothesis, alternative hypothesis we have discussed. Null hypothesis is statement of no difference, status quo. which is common sense, which is happening. What I'm interested is in the research hypothesis, right? And that is where I wrote based on a substantive theory, right? You should have some information. It cannot be only my assumption, because my assumptions will be completely different from yours. It need to have some basis of creating a hypothesis, right? Otherwise, same research question, you will create different hypothesis. All of those 70 or 60 students who are there will form different hypotheses. It has to have certain theory, certain logic, certain basis of creating a hypothesis. How will you get that basis? Secondary search, qualitative study, right? Or your own experience, right? That will give you some basis, right? So those are the few things what I wanted to discuss today. Any questions or any doubt? So this is the
Can you please explain the first assumption in hypothesis testing?
all statistical tests assume random sampling, right? So the information or
You
the
were
data.
giving the example of summer internship. Can you please repeat that?
Yeah, let's think about summer internship and you are doing it for a Reliance retail. Okay. And you want to understand the average waiting time in a queue. How much time customers are waiting in the queue. And that is, and you have done some Google search and you find out that in India, generally on an average, people wait for 25 minutes, right? And you want to validate that, whether it is true in Odisha or for a particular Reliance outlet or Big Bazaar, right? So when you go and try to collect data, right? So you might say that, okay, I stay in Kolkata or I stay in Bhubaneswar, this location. The nearest place to me is this 2 kilometers down the line, there is a Reliance Retail or Big Bazaar. It will be easy for me to go there in a particular afternoon, collect data. So I'll just see that, okay, on an average, I'll wait there for 3 hours. And on the 3 hours, I'll just write down, observe each customer, how much time they're waiting. That is very easy to do. You know that when the customer came and or you can just take a video also, right? With a permission from those retail managers, you can take a video. If video is not possible, you stand and look at how much time a customer is waiting, right? You collect data of 100 customers or 200 customers. You come back and do all those analysis, right? Whether it is actually greater than 15 minutes or 20 minutes or 25 minutes, whatever the data point. Now the question is whether that will be random, right? Why it is not random? Because on the particular day you have chosen, right? Some customers who regularly come might not be there, right? Or it might be a particular weather day. Let's say it is a holiday or it is a something, it is raining, right? Some customers who wanted to come, they are not there. Or the store which you have gone there, right? The nearby store, because it is 2 kilometers nearby your place, that doesn't actually represent other stores, right? Other stores might be bigger in size, bigger counter, the waiting time might be smaller there, right? So there are a lot of things which are not common, right? But going just to because the store is nearer to your place and you have some time on the afternoon, you go and collect data, and based on that, if you create a research, that will be biased, that will not be random, right? Because the average time they are spending, different customers will be different across different stores. You have not taken that into consideration. You have not done on different days also. You have not collected data on different days, because on a weekday and a weekend, the waiting time will be completely different. If you have gone on a weekend, you will not have information on a weekday. If you have gone on a weekday, you will not have information for a weekend, right? So whenever you are framing this kind of hypothesis, remember that as much as information you are able to put in your data point. So if I want to
What if
design
I do the sampling for 7 days in a week?
7 days a week across different
I do-
stores, across different time, if you are able to do that,
Okay.
that will justify the randomness.
Random sampling.
Sir, can you tell about type 1 error and type 2 error, sir? I am little bit confused in that.
Yeah,
part.
we'll come to that. We'll come to that. So we have not completed hypothesis. That lot of things we have not discussed. Significance level we have not discussed. Once you discuss significance level, we have to discuss confidence interval. From there, we have to discuss type 1, type 2 error. Don't worry, we will come to that. So now the question is central limit theorem. Hopefully, all of you have an understanding. then what is written here is a independent and identical distributed. If some of you are getting into analytics, right? So this is a very standard question. Everybody is get asked during their data analytics interview. In case some of you get through those interviews. So somebody was asking with replacement or not. Yes, with replacement, population with replacement. But now my question is, what does this IID means? Independent and identical distributed.
Sir, in the samples, what are the things that we have taken? Those variables are independent to each other and they are identical to the person who is taking the data.
It is not about the sample, right? It is IID population. Your population need to be independent and identically distributed.
Independent to each other. Yes, sir.
So what do you mean by that? When I say independent to each other, what do I mean by that? Think about a 52 deck of cards, right? The example what I'm giving, right? If some magicians tell that I select a card randomly, right? You shuffle it and randomly select whether that population of 52 cards, right? If I take that deck as a population, will that be independent and identically distributed?
Yes, sir. The
Yes,
card
sir.
itself that is being
Yes, sir.
picked, it is
Yes, sir.
identical, identified.
How do you say that it is identical?
No,
If I
sir.
say that, okay, heart of 6, all the cards,
Sir,
how
it
many?
is independent, but it won't be identically distributed.
Identical.
Like we can't. Yes.
Correct, because all the cards will have a different distribution. The card having
Different distribution.
different colors, red will be 26, black will be 26. The different symbols, each of them are 13, 13, 13. Each of them have a different type of distribution. So distribution of each of those cards will be completely different. It is not same, right? So, but when I'm talking about all the student, right, unless there are some other parameters, right, which is not known to us, all the parameters which I'm going to measure, right? If I measure your age, if I measure your weight, whatever other information or your scores in your kind of quiz or all those things, right? Assuming they are independent, but again, you can question that, okay, I copied from some other person, so my score will be almost same, right? So I am believing that you have not copied from someone else, so your scores are independent of each other. Otherwise, what will happen? Somebody has answered all 330 or 200 students, which is happening on the online classes, online exams. Ideally, that is not independent because somebody's mark is dependent on somebody else's mark, right? If like actual, if you go by the literally meaning, right? But ideal case scenario, if everything has been taken care, the population which I'm going to study. All those variables are independent and identically distributed. Distribution of those individual variables, whatever I'm measuring, distribution will remain same, right? Which is not true for a deck of cards. Wherever happens, each of those cards of different colors, different numbers have a different distribution. Getting two, that has only there are four possibilities, four different colored, four possibilities. But getting a two of whatever other color, black of black diamond or a heart, right? That will be a different. So each of them will have a different probability, different distribution, right? So whenever somebody talks about this example, you can always bring that example of a deck of cards, right? Otherwise, most of the continuous data which is naturally happens, right? Age, weight, your performance in a exam, assuming that all other parameters have been taken care of, right? Will be identical and independent. Sorry, identical and independent distributed, right? Probability of that person being selected, chosen, all will remain same, right? Otherwise, what will happen? Each of the variable will have a different distribution. So when you take a sample out of that, each of the sample also will have a different distribution, which will not give a correct result for your central limit theorem. Okay. So central limit theorem, which is the basis of all the hypothesis testing we are going to cover, talks about something called sampling distribution, which is a hypothetical or theoretical distribution. Using that distribution, what I am telling that for random samples we take for the population, we can compute the mean of the sample means. So mean of the sample means all the theoretical samples, if I take mean of that, so mu x bar will be equal to population mean. Population mean is mu. And the standard deviation of the sample mean, right? Standard deviation is the difference from the mean, the distance from the mean, right? Will be something known as standard error. Standard error is nothing but population standard deviation divided by square root of n. N is nothing but number of your sample size, right? The like in your sample, let's say you have taken 30 or 64 or 100. So that 100, 30 or 64 becomes your sample size or n, right? So how to use that and how it will help us to get an answer for, let's say, those two questions what we discussed today. So in the next class, we'll discuss that. There are few things we have not discussed: confidence interval, level of significance, type 1, type 2 error, right? Those three things and examples we'll discuss in the next class. And any last
Sir,
questions
also-
before we close? Yeah.
Sir, can you also share this slide? We haven't got
Yeah,
this
yeah.
slide.
I'll share today.
Yes.
Okay. Chalo, take care. We'll meet next class.